So let me check my audio. Yeah, it is catching up. Okay. So now we are starting a new topic: energy, power, and non-energy, non-power. So in this topic, so first of all, we'd like to see what is NEMP, non-energy, non-power. So now I'm going to talk in Hindi. Okay. अगर इसका एम्पलीट्यूड कहीं पे भी इंफिनिटी चला गया, इसका मतलब वो नॉन एनर्जी नॉन पावर है. Okay. It means that at any point if its amplitude reaches infinity, then it is called as non-energy non-power. So as you can see, these all are the example of non-energy non-power. Del T, it reaches infinity. RT, it also reaches infinity. MIT, it also reaches infinity. LNT, and 7, 6, and 8. Okay, so what you have to uh, what you have to remember. Okay. What you have to remember in this NEMP non-energy non-power is you can recall in Hindi अगर उसका एम्पलीट्यूड कहीं पे भी इंफिनिटी चला गया, इसका मतलब वो नॉन एनर्जी नॉन पावर है. Okay? Now energy signal. So energy signal must have a finite energy for infinite possible duration. Okay? And this is the basic power formula energy by time. So if a signal is energy signal, then power is zero. Okay. So we have to remember that the energy signal must have a finite energy for an infinite possible duration. So about energy signal, if it is periodic, non-periodic. If it is periodic, it can never be an energy signal. If you can see any periodic signal, it can never be an energy signal. Okay. Now moving to non-periodic signal. Now condition is that if the amplitude is finite, so we have to check duration is finite and duration infinite. So if the duration is finite, then it is a amplitude finite and the duration is finite, then it is an energy signal. Okay, and if the duration is infinite, then the amplitude at t is equal to infinity or in discrete signal and is tend to infinity, the value should tends to zero. Okay, so at infinity, if the value tends to zero, then also it is an energy signal, and the condition is that amplitude must be finite and duration is infinite, then the amplitude at infinity must tend to zero. So this is a formula of energy that we have to remember. Integration minus infinity to infinity modulus. Do remember there is a modulus in this formula. Okay. So integration minus infinity to infinity modulus xt square dt. It is in the time domain, and in the discrete domain it is sigma. So sigma minus n is equal to minus infinity to infinity modulus x and whole square. If we open this, then it is x minus 1 modulus whole square plus x0 modulus whole square plus x1 modulus whole square and so on. Do remember this. As long as this xt is real, then modulus of x square is equal to, we can write this modulus of x square is simply x square t. Okay, so these are some examples. So we are now calculating the energy. So x is equal to p plus gt e to power minus kt ut is greater than 0. So now what is the energy? So we find this x, so integration minus infinity to infinity, as we can see that this is not a periodic signal integration, because a periodic signal can never be an energy signal. Okay, so integration minus infinity to infinity, we write e plus gt e to power minus kt ut in this whole is in modulus whole square dt. So now we separate this and this differently, so modulus e plus gt whole square and modulus e to power a to dt whole square dt. Now this Now we know the p plus jq whole square is, and p plus jq modulus is under root p square plus q square. And if you take the square of that, we will simply get p square plus q square. Okay. So we take this constant p square plus q square outside, and inside the integration there is integration 0 to infinity. So now limit was minus infinity to infinity, but it changed to 0 to infinity because of ut. Because ut signal is defined from 0 to infinity. So because of ut, this limits of this integration changes to 0 to infinity. And inside, because of this square, there is a 2 coming into picture, where e to power minus 2 at dt. Okay. So now um, integration minus infinity for t square plus t square is power minus 2 at t square. Okay, it's showing equals to t square. Okay, so p square plus q square upon 2. Okay, upon 2. When we solve this integration, we get 1 upon 2. Okay, let me check. Now we get this 1 upon 2. Okay, so let's see, p square plus q square as it is, and the coefficient of t is 2. So we write 2. Now, if you solve this, you get 2. Okay? I tell you how. It is. This is minus sign. Okay. So you write infinity, so e to the power minus infinity, it is 0. So it's 0. And e to the power, it is 0. And minus 1. So this, this integration result should be 1, but the coefficient is not, the coefficient of t is 2, so it's 0 minus 1. So its integration is minus 1, and because this coefficient is minus 2, so we divide it by on a minus 2. So the minus 2 and this minus 1 result cancel out, and we get simply 2 in the denominator. So another example. So x is given as p plus j, p to power 80 u minus t, where a is greater than 0. So we have to find the energy of this given signal. So we apply the formula, which is integration minus infinity to infinity, and we write it x in the modulus, and we take the whole square dt, and we then separate this p plus gt differently, and e to power 80 u minus t differently. Okay, now we know that p plus modulus of p plus gt is under root p square plus q square, and the square of p square plus q square is square of under root of p square plus q square is simply p square plus q square. Okay? So we write outside p square plus q square. Now inside integration minus infinity to infinity, because of these two, they do each part to a to come into picture, and this u square minus t come into picture. Okay? So as you know, ut into ut into ut into ut into ut up to n time is simply ut, and u minus t minus t u minus t u minus t u minus t up to n is simply u minus t. So this u square minus t is simply u minus t. So now it is minus t, so minus infinity to 0. Okay, if it was simply ut, then 0 to infinity. So the limit changed from minus infinity to infinity from to minus infinity to 0 and e to the power 2. Now if you solve this one, let me show you how. So you will put the upper limit, so e to the power 0 is 1, so 1, and e to the power minus infinity is 0. So you will get the uh, result of this integration 1, so 1 minus 0 is 1. Now the coefficient of t is 2a, so we divide by 2a. Okay, so the energy got the energy we get here is p square plus q square upon 2a, and this is in joules. Okay? Do remember that we get the same energy in both the cases. So now let's take an example of a discrete signal. So x1 is given as 1 plus 2j plus 3j minus 4j and 4 plus j. This arrow shows that it is at the origin. Okay, so it is the most simple format because in discrete it is way more simple, simpler as it was in time sequence. If you go here, please focus on my person. You can see energy signal is sigma and this is a minus infinity to infinity modulus of x and whole square. And when we expand that, we put different values of n into this function xn, and we take the modulus and take the square of the modulus, and then we simply add them and we get the result. Static energy. Yeah, it is that simple. So the same process we are applying here. So we are saying one, simply write one whole square. 2j modulus of 2j whole square. 3j modulus of 3j whole square. Minus 4j modulus of minus 4j whole square. 4j modulus of 4j whole square. So we get 1 square 1. 2j whole square is 4. 3j whole square is 3. Minus 4j whole square is 16. And 4 plus j modulus is under root 16 plus 1. And when we take the square root, we get 70. Okay. Now these are some basic formula that we have to remember. As you know, a plus b whole square is a square plus b square plus 2ab. So we break the 2ab into ab, and we do remember modulus a plus b whole square, which is modulus a square plus modulus b square plus ab conjugate plus a conjugate b. Yeah. And you can also remember it like that a plus b into a plus b conjugate, which gives us a plus b into a conjugate plus b conjugate. Okay, so let me check my audio. Yeah, it is catching up. Okay, so now we are starting a new topic: energy, power, and non-energy, non-power. So in this topic, so first of all, we'd like to see what is NEMP, non-energy, non-power. So now I'm going to talk in Hindi. Okay, अगर इसका एम्पलीट्यूड कहीं पे भी इंफिनिटी चला गया, इसका मतलब वो नॉन एनर्जी नॉन पावर है. Okay? It means that at any point if its amplitude reaches infinity, then it is called as non-energy non-power. So as you can see, these all are the example of non-energy non-power. Del T, it reaches infinity, RT, it also reaches infinity, and RT, it also reaches infinity, LNT, and 7, 6, and 8. Okay, so what you have to uh, what you have to remember, okay, what you have to remember in this NEMP, non-energy non-power, is you can recall in हिंदी, अगर उसका एम्पलीट्यूड कहीं पे भी इंफिनिटी चला गया, इसका मतलब वो नॉन एनर्जी नॉन पावर है. Okay? नॉन एनर्जी सिग्नल. So energy signal must have a finite energy for infinite possible duration. Okay? And this is the basic power formula, energy by time. So if a signal is energy signal, then power is zero. Okay. So we have to remember that the energy scale must have a finite energy for an infinite possible duration. So about energy segment, if it is periodic, non-periodic. If it is periodic, it can never be an energy signal. If you can see any periodic signal, it can never give an energy signal. Okay. Now moving to non-periodic signal. Now condition is that if the amplitude is finite, so we have to check duration finite and duration infinite. So if the duration is finite, then it is a amplitude finite and the duration is finite, then it is a energy signal. Okay. And if the duration is infinite, then the amplitude at t is equal to infinity or in discrete signal and is tends to infinity, the value should tends to 0. Okay. So at infinity, if the value tends to 0, then also it is an energy signal, and the condition is that amplitude must be finite and duration is infinite, then the amplitude at infinity must tend to 0. So this is the formula of energy that we have to remember. Integration minus infinity to infinity modulus. Do remember there is a modulus in this formula. Okay. So integration minus infinity to infinity modulus xt square dt. It is in the time domain, and in the discrete domain it is sigma. So sigma minus n is equal to minus infinity to infinity modulus x and whole square. If we open this, then it is x minus 1 modulus whole square plus x0 modulus whole square plus x1 modulus whole square and so on. Do remember this. As long as this x xt is real, then modulus of xt square is equal to, we can write this modulus of xt square is simply x square t. Okay. So these are some examples. So we are now calculating the energy. So x is equal to p plus gq e to the power minus kt ut is greater than 0. So now what is the energy? So we find this x, so integration minus infinity to infinity, as we can see that this is not a periodic signal integration, because a periodic signal can never be an energy signal. Okay. So integration minus infinity to infinity, we write p plus gq e to the power minus 80 ut in this whole is in modulus whole square dt. So now we separate this and this differently. So modulus p plus gq whole square and modulus e to power 80 dt whole square dt. Now this now we know that p plus gq whole square is, and p plus gq modulus is under root p square plus q square, and if you take the square of that, we will simply get p square plus q square. Okay. So we take this constant p square plus q square outside, and inside the integration there is integration 0 to infinity. So now limit was minus infinity to infinity, but it changed to 0 to infinity because of ut, because ut signal is defined from 0 to infinity. So because of ut, this limits of this integration changes to 0 to infinity, and inside, because of the square, there is a 2 coming into picture, where e to the power minus 2 at dt. Okay. So now um, integration minus infinity for t square plus k square is power minus 2 at t square. Okay, it's showing little t square. Okay, so p square plus q square upon 2, okay, upon 2. When you solve this integration, you get 1 upon 2. Okay, let me check. Okay, this 1 upon 2. So let's see, p square plus q square as it is, and the coefficient of t is 2. So we write 2a. Now, if you solve this, you get 2a. Okay? I tell you how. I tell you. This is minus sign. Okay. So you write infinity, so e to the power minus infinity, it is 0. So it's 0. And e to the power, it is 0. And minus 1. So this, this integration result should be 1, but the coefficient is not, the coefficient of t is 2, so it's 0 minus 1. So its integration is minus 1, and because this coefficient is minus 2a, so we divide it by on a minus 2a, so the minus 2a and this minus 1 result cancel out, and we get simply 2a in the denominator. So another example. So x is given as p plus j, p to power delta u minus t, where a is greater than 0. So we have to find the energy of this given signal. So we apply the formula, which is integration minus infinity to infinity, and we write the xt in the modulus, and we take the whole square dt, and we then separate this p plus gt differently, and e to power at u minus t differently. Okay, now we know that p plus modulus of p plus gt is under root p square plus q square, and the square of p square plus q square is square of under root of p square plus q square is simply p square plus q square. Okay? So we write outside p square plus q square. Now inside integration minus infinity to infinity, because of these two, they do e to power t a2 come into picture, and this u square minus t come into picture. Okay? So as we know, ut into ut into ut into ut into ut up to n that is simply ut, and u minus t minus t u minus t u minus t u minus t up to n is simply u minus t. So this u square minus t is simply u minus t. So now it is minus t, so minus infinity to 0. Okay, if it was simply ut, then 0 to infinity. So the limit changed from minus infinity to infinity from to minus infinity to 0 and e to power 2. Now if you solve this one, let me show you how. So you will put the upper limit, so e to power 0 is 1, so 1, and e to power minus infinity is 0. So you will get the result of this integration 1, so 1 minus 0 is 1. Now the coefficient of t is 2a, so we divide by 2a. Okay, so the energy got, the energy we get here is p square plus q square upon 2a, and this is in joules. Okay? Do remember that we get the same energy in both the cases. So now let's take an example of a discrete signal. So x1 is given as 1 plus 2j plus 3j minus 4j and 4 plus j. This arrow shows that it is at the origin. Okay, so it is the most simple format, because in discrete it is way more simpler as it was in time sequence. If you go here, please focus on the person. You can see energy signal is sigma, and this is a minus infinity to infinity modulus of x and whole square. And when we expand that, we put different values of n into this function xn, and we take the modulus and take the square of the modulus, and then we simply add them, and we get the result. That is energy. Yeah, it is that simple. So the same process we are applying here. So we are saying 1, simply write 1 whole square. 2j modulus of 2j whole square. 3j modulus of 3j whole square. Minus 4j modulus of minus 4j whole square. 4j modulus of 4j whole square. So we get 1 square 1. 2j whole square is 4. 3j whole square is 3. Minus 4j whole square is 16. And 4 plus j modulus is under root 16 plus 1, and when we take the square root, we get 70. Okay? these are some basic formula that we have to remember. As you know, a plus b is the whole square, a square plus b square plus 2ab. So we break the 2ab into ab, and we do remember modulus a plus b whole square, which is modulus a square plus modulus b square plus ab conjugate plus a conjugate b. Yeah. And you can also remember it like that a plus b into a plus b conjugate, which gives us a plus b into a conjugate plus b conjugate. Okay. Okay, let me check my audio. So it is, yeah, it is open. So now we are going to start another topic, that is energy of combination of basic signals. Earlier that we have earlier we have studied how to find the energy of a signal, a single signal. Now we are going to study the energy of combination of basic signals. So here Ex is equal to integration minus xt to integration minus infinity to infinity modulus x is whole square dt, which here xt is integration minus infinity to infinity. Now at the base of xt, we write x1t is x2t for whole square dt. Okay, so now we break this x1t whole square dt and x2t whole square dt separately. Okay, so we can write ex into integration. Uh, hmm, integration minus infinity to infinity xt x1 t whole square plus minus infinity to infinity x2 t whole square plus integration minus x1 t x2 conjugate dt plus my same integration x1 conjugate x2 t dt. So we do not know that so this term, focus on my cursor. This term and this term comes from the formula that we have studied here. Here, this is a and this is b. This is modulus a square. So modulus a square, that is this, plus modulus b square, that is this, plus ab modulus, sorry, ab conjugate, that is this, and a conjugate b, that is this. Okay. So this is the formula of energy of x1 and this is the formula of energy of x2. So we can write that Ex is Ex1 plus Ex2, we get these two extra terms, integration minus infinity to infinity x1 to x2 conjugate tdt plus integration minus infinity to infinity x1 conjugate to x2 tdt. Okay, so uh, at this time, at this point, we do not know that x1 and x2 are also known. If x1 and x2 are also known, then we know that the inner product is 0. So these two terms will get eliminated because they are equal to 0. So we get ex equal to ex1 plus ex2. So note that if k energy signal from a set of mutually oscillating signals, for example, xt is equal to x1t up to xkt, so energy will be, and they all are orthogonal. So these the energy of these signals will be directly implemented ex1 plus ex2 plus ex3 plus up to exk if we know that they are set of mutually orthogonal signals. Okay. We're not going through this. I can go through this offline. So the difficulty 5 are very important. These are some examples. Let me go to the examples. Okay. So example one. Question number. X is equal to p to the power minus a modulus t where a is greater than 0 is given to. So first of all, we have to take this is xt into a simpler equation. So we have to take this modulus. So if we take 2 to be positive, then we multiply e to the power minus a to which ut. And if we take 2 to be minus 2, so we have to multiply it by u minus 2. So x is equal to e to the power minus a to ut, which is that we call x12, and plus e to the power a to u minus 2, which is the second term that we are calling x2. So now x1t and x2t are also known because you can see the modulus of t here is minus a and the modulus of t here is a. So both of omega are different. Okay, so omega 1 is not equal to omega 2. So both x1 and x2t are orthogonal. So when we found out that both are orthogonal, now we can directly write the energy as E1 plus E. Okay, so we have seen earlier that energy of this image is 1.2 and energy of this image is 1.2. So we can simply add it to 1 joules. Okay? Now you can also find it by simply by taking the modulus of this e to the power minus a to ut integration e minus infinity to infinity e to the power minus a to ut modulus whole square. Okay? So integration minus infinity to infinity will be converted into base infinity because of ut. And when you want to take uh, modulus of e to the power minus 80, it will remain as e to the power minus 80 and the square term will give us e to the power minus 280. Now when you're going to apply integration 0 to infinity, so e to the power minus infinity is 0 and e to the power 0 is 1. So it will give us minus, but here the coefficient of t is minus 8. So we divide it by minus 8. So minus 1 divided by minus 8 will give us 1 upon 8. And similarly here we also get 1 upon 2. So we get 1 upon 2. So let me check how this one point will come to picture. So let me solve this. Okay, I'm going to solve it on screen. So this is bandit of I'm using bandit of. Yeah, yes, I know. It's just I don't know about the audio that time. So let's solve it. So we select pencil. So this is our example. So we write integration minus infinity to infinity modulus e to the power minus 80 qt whole square dt. So as you know, qt square is ut. So this integration will change to 0 to infinity. Okay, and this modulus will give us e to the power minus 280 Now when put the limits, so e power minus infinity gives us 0 minus e power 0 gives us 1, so it gives us minus 1, but here the coefficient is minus 2, so we divide it by minus 2, and because of this minus minus, we get cancelled, so we simply get 2. So this is how we get 2. Okay, and similarly, this is also step 4. Okay, now moving forward, so you do remember that minus e to power 80 ut gives us 1.0, and ut and e to power 80 u minus c gives us 1.0. So adding them will give us 1.0. So this is the method number 2 by the graph. So this is e to power minus a minus c. So if we take the positive one, so this is positive. So e to power minus 82 gives us a curve like this. And if we take the negative, it will give e to power 80. It gives us the curve number 1. And you can see 1 and 2 are both positive. So as I have proved above that this is true, so yes. So these are important rules that we have to remember by heart, because these are very useful for us in the exam. So let's go through them. So as I have proved earlier that e to the power minus 80 and a is greater than 0 gives us 1.02. Now e to the power 80 and u of minus 2 a greater than 0 gives us 1.02. So now e to the power minus a modulus of 2 a of greater than 0 is the summation of the above two. So summation of 1.0 plus 1.2 gives us 1.8. Okay. Now p plus jq is to power a to beta. So as you know, uh, while taking the modulus and square of this term, it will give us p square plus q square. Okay, and we have already known that p to the minus 80 gives us 1.2. So you can simply run it by constant without any addition. So this is the first one. P plus jp e to the power 80 u minus t. So it gives us p square plus q square 1.0. Okay, so p square plus the j cube e to the minus a modulus c gives us the summation of the above two. So it will give us p square plus q square upon a. Okay then, so this is the seventh one. This is q points. So do remember that. So minus q by 2 select q by 2, and the amplitude is k. So what is the energy of the signal? If you take the modulus square of the signal and multiply it by time period t, that will give us the energy. Okay. This is example. This is the modulus. Take the modulus. Take the amplitude. This is the amplitude. Sorry. Take the magnitude of the amplitude square and multiply it by time period. Gives us the energy. So this is a triangle. Okay. So here case is different. Okay. Now you can see this is uh, minus t by 2 to t by 2, and if you just scale to multiply, take the modulus square of the amplitude and divide it by k, energies. And here modulus of k is the peak value. It is not amplitude, I'm sorry. It is peak value. And if you take the square of the peak modulus square of the peak value divided by c into time period, it will give you energy. Similarly here, it is also a triangle. Doesn't matter it is a equilibrium triangle or any triangle, it is a triangle. So take the peak value modulus, square it, divided by 3, and then multiply it by the time period, whatever is the time period. Okay? The final point divided. The difference between the final and the initial point is your time period. So as you can see, this is also a type of triangle. It is sort of signal, we all know that, but it is a triangle. So take the value, take the peak modulus of peak square divided by 3 into the. There are some examples of it. So if you want to solve it with the basic method, that is break down this whole signal into steps. Break down this into two domains. This is x1, this is x2. X1 is t plus 1, x2 is minus 1 by t2 plus 1. So method 1 integration minus 1 into t. Okay? Modulus of this x2 and this we divide into x1 and x2 as you can see here. Now we put the value of x1 and x2 here. Okay? It will give us the first one will 1.2 and the second term gives us 2.2, which gives us 1. Method 2. As you can see, this triangle and this triangle are orthogonal to each other. So we can find that energy of both of them separately. If you find the energy of this signal, see where the cursor is, you could find it by peak value modulus square divided by 3 into time period, that is 1. This triangle peak value 1 modulus square divided by 3 into time period, that is 2. So first term gives me 1 by 2, second term gives me 2 by 3. And the most efficient method and the method that we are going to use in the exam is this method. It doesn't matter that you go with this basic method, okay, but it is not useful for us in the exam. But this method that we see this triangle has two different triangles. See, it is see this as a whole one triangle. Okay, don't separate, don't make two different triangles. You can see it is as a one single unit of one triangle. Okay? So take the modulus of the peak value, then square it, okay, divide it by 3, okay, and multiply it by multiplied by the time period, whatever is the time period. Time period here is 3. 1.3 whole square is 3 is 4. Okay. This is the most useful method that we are going to use in the exam. Okay. So now moving forward, these are the some signals and these are the energy of that signal that is helpful. So we are going to learn it. If x is the signal, if energy is Ex, then shifting does not affect it. Time scaling does not affect it. Time reversal does not affect it. Time scaling does affect it. You can see here x80 is gives us e to power ex upon modulus a, and x minus 80 plus t gives us ex upon modulus a. Okay, so shifting doesn't change energy, but yeah, time scaling does change it. So now if we multiply it by k, now amplitude scaling, it also affects the energy. So multiply it by, take the modulus of amplitude, square it into energy divided by the time period of the time square. Okay, and this is in this two times signal. Okay. So energy of sinusoidal pulse this is the method. This is the peaking. You can see. Okay, you see it. Take a screenshot if you want to, take, see it after. So this is nothing, just a simple derivation. So, that we come to the conclusion that Ex is a square by t, a square by t minus a square sine 2 omega t upon 4 that is function. Okay. So now let that 2 omega t is n pi, that is integer. Now time period is 2 pi by omega 2 omega, that is 2 n pi by 4 pi, that is n by 4. So time period comes out to be n upon 4. The energy, the energy that we have to remember for sinusoidal signal is a square by 2 to t. Okay? A square by 2 into t. As you know that power is energy by time, so power is a square by 2 and energy is a square by 2 into t. Okay? So let's take these two examples. This is the figure. We'll break it into three parts. All of these three parts are mutually orthogonal to each other. So the energy of E1 is modulus the 2, and this is modulus of minus 2 square into 3 minus of 2 plus modulus of 3 square equals 3, which gives us 3 joules. Okay, 37 joules. Okay, this is also we divided into three parts. Okay, this triangle, this rectangle, this triangle, this triangle, modulus of the peak value divided by 3 into the time period, that is 4. Okay, now this peak is minus 2, amplitude is minus 2, so we take the modulus of amplitude divided by a square. Okay, and now we multiply it by the time period. This is triangle. Okay, take the peak value, take modulus of the peak value, square it, divided by 3 with the time period. This is the, and then this is 2.3 change. So good night everyone. This is night time. So this is the basic signal understanding system. So in the last lecture I have taught till here. We are studying energy of sinusoid signals. Okay. So what we have to take from this topic, what we have to remember, the only thing that that will be going to be important in the exam is that the energy of sinusoid signals are a square by 2 into time period. Okay, and the condition when the t the time period is on the form of n upon 4f. That's it, nothing more. But for your information, I will explain it. So this is the basic energy formula. Okay, more or less you can see. I'm not going to say anything. You can figure it out by yourself. Okay. So in the end, this energy formula comes out as a result: a square by 2 into time period minus a square sine 2 omega t upon 4 omega. So in this term, we eliminated this term by letting 2 omega t equal to n pi, and by putting t is equal to in the form of n by 4. So we say that when t is in the form of n upon 4f, then energy will be a square by 2 into time period. Now, if you want to find the power of the sinusoid signals, so what is the power of the sinusoid signals? The power of the sinusoid signals will be a square by 2. Why? Because why? Because power is energy by time period. So when we put energy by time period, to this t and t we cut out, and we get, for example, I show you. Let me write P is equal to E by time period. So when we write E equal to A square by 2 into time period divided by T, this T will be cancelled out and we get A square by 2. Okay? So yeah, this is how we get the power. Now moving forward, these are the examples that we are going to solve. Okay, first, as we can also see all of this. This is a graph, and individually we divide it into three parts: a rectangle, and a rectangle. And both of these three parts, 1 to 3, are mutually orthogonal, as we have studied earlier. So now we can, if you want to find the energy of these three rectangles individually, we can simply uh, write it as E1x, EX1 plus EX2 plus EX3. Okay. So now this one, the altitude is 1, so we take modulus of 1 and square it, and time period is 2, so we multiply it by 2. So plus the second one, the altitude is minus 2, so we take the modulus of minus 2 and we square it, and then we multiply it by 3 minus 1 is 2. The time period plus the last one. The amplitude is 3, so we take the modulus of 3 and we square it, and now the time period is 3, so we multiply it by 3. So 37 joules comes out with the answer. Okay. Now, these are some other examples. Okay. So let me go through one more, then I'll be moving forward. This is also, for example, this graph is given to you and they are asking about the energy of the star. So we divide this into three parts: one rectangle, one triangle, one rectangle, and another triangle. Okay. So what we have studied that this is a peak value of the triangle. So take the modulus of the peak value, square it, and then divide it by 3. Okay. Now multiply it by time period. So time period is minus 2 to 2, so it's 4 plus now this one. So it is a rectangle, okay. So its amplitude is minus 2. So you take the modulus of minus 2, then square it, and the time period is 2, so you multiply it by 2. Now this one, its amplitude, its p value is 1, so we take the modulus of 1 and square it and divide it by 3. Okay. Now this time period is 2, so it multiplied by 2, and 62.3 joules comes out to the energy. So and so on. These are the examples, and you can take a screenshot of this page. You can see it further. Okay. Now let's go to this fourth question. I have marked this. I have highlighted this question. So maybe something is special about this question. So it's not working. Okay. So what about this question? X is given to t minus u, ut minus q t minus 1. Okay. So we have to find the energy in the second. It's 2t. Okay, so now what we have done, we make a break into two graphs. So we make yt equal to 2t and this ut minus t minus t. This. Now we multiply both of them, and when you multiply it, concentrate on the cursor, we only expect to get this. Okay, this. We, the joining of both of these lines is not that we get, but we, as we know that when the graph is hanging in signal system, we simply complete it. So when this is the resultant graph, so yeah, this example shows us that this looks like a complex, something dangerous, but if not, simply what we have to do is break it in two parts, make two graphs, 1 of y is equal to 2t, okay, by 2t, the slope is 2, okay, the slope is 2, and this 2, this 1, 2 into 1 into 2 is 2, okay, like that. And make another graph of this 0 to 1, then multiply it. So you get a triangle from 0 to 1 with a peak value of 2. So take a modulus of 2 square divided by 3 into time period 1. 4 by 3 is the answer. Okay. Now, now moving forward. Okay. So take a look on this example. X is given as 2 minus modulus t, where modulus t less than equal to 2, else 0. Okay. Now, if you do remember that when we have studied, actually I have not made a video of it, but I think you should know that this is can be written as a standard term for a triangle. Okay, you can write it like this. If we take 2 common, so we can write 2 1 minus modulus t upon 2. The limits will remain same. Modulus t less than equal to 0 and 0 elsewhere. So we have studied in lecture number, I think early, I think fifth or sixth lecture, I think, that A bracket 1 minus modulus t upon capital D, where modulus t is less than equal to capital T and 0 elsewhere. This, when you see a function like this, it is of a triangular function where this A is the peak value and where this time period is minus t to t. So yeah, if you find the time period of this one, let's say for example it is taken as 2 peak value and t is taken as 2. So take a take a modulus of p, 2 square divided by 3, and the addition between the time period is 4. So 16 by 3. Okay. So when you uh, uh, want to directly write the time period, okay, so this t is 2 and this 4 is 2. Okay, so if you want to write from here to here, so you have to divide this 4 by 2, divide this capital T. Okay. Now I have an important observation that we have to observe here, that we have a lot of help in the upcoming lectures. And I do ask you about, do you remember that I'm going to tell you right now. Okay. So this is the triangle. So we know how to find energy of this triangle. It's a basic term. Okay. So if we go with the basic formula, that is modulus xt square dt integration minus infinity to infinity. This omega is a dummy variable, as we already know. So you can write anything: x omega, xt, xy, anything, xz, anything. Okay. So what is the energy of this triangle? It's that if you take the uh, modulus of this peak value a, okay, then you square it, then you multiply it by 3, and then you multiply it by the time period, that is minus t2 to t2, so the time period is t. Now absorb it. So basically what we have to remember from here, that the integration of minus infinity modulus of omega square d omega is equal to modulus a square by 3 into t. So we have to remember that the integration of this term, this integration that looks so complex, the result of this integration is so simple that we have to remember that. That is modulus a square upon 3 into the time period. Okay. Now, okay. So this is an example. So while looking at it, I will break this into two graphs. First is this triangle, and the second one is this. So, so what we have seen that these, let me name them 1 and 2. Okay, okay. This is one, and this is 2. Okay, so 1 and 2 are not in mutually orthogonal. As you can see, they have shared the same time period. If you multiply each of one with the other, you will not get 0. Okay, so we have to find the long-term method of finding energy, that is simply first by ex1 plus ex2, then this term plus 2 integration minus infinity to infinity x1 to x2 to dt. So how x1 to and x2 to dt comes out to be, for example, this x2, yeah, this x2, if we write it uh, correctly, okay, once again, here we go. This x2 conjugate is a graph. Okay, this is a graph. So in a graph will always remain a graph. So we can write it simply as x2. Similarly, in the other case, when x1 conjugate is written, so it is a graph. Okay, the conjugate, it is a graph of real values. Okay, no imaginary values. So conjugate will not affect any the shape of the graph. Okay, it will remain as it is. So we can simply write this as x1. Okay, so the term that how this term come out to be. As we all know, we write even ex1 plus ex2 plus integration minus infinity to infinity x1 to x2 conjugate dt plus integration minus infinity to infinity x1 conjugate x2 d dt. So in this case, x2 conjugate is x2, x1 conjugate is x1. So both terms are equal. So we add them, and there how this 2 comes. And if you see carefully, this is not, this is this integration actually the area between the graph. Okay, the area between the graph. So when you multiply x1 and x2, you will get this graph. Okay, so this integration actually the area between this graph. So what is this? You write 2 here, half base into height. So you write base is 2 and height is a square. So this is the answer of the energy. This is non-orthogonal signal. Now moving forward. Okay. So similarly, this is also an example as the above. So you can take a screenshot and you can see it afterwards. Okay. You can take a screenshot. You can see it afterwards. Now this new topic, discrete time energy signal. Yeah. So energy in this again summation n is equal to minus infinity to infinity modulus of xn का square. So if you open it, it will x minus 1 का square modulus plus x0 modulus square plus x1 modulus square and so on. So if that I have told earlier also in my previous lecture, it's not the previous lecture, it is in the same lecture. You can see that if x1 is real, then conjugate of x1 square will be written as simply x square x1 square. As you can see, modulus xn whole square is written as x square n. We remove the modulus. And now, well, this is, let me change color of it. What you will like. Okay, 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 okay. So, pencil. Yes. So this is the formula when, okay, this is hell of a spell. When the so I'm writing it by my mouse, so you can feel my struggle, bro. Yeah, you can. Okay, the recording is still going on. I thought that I have stopped the recording. So this is the formula of orthogonal. Sorry, when the x1 and x2 are not orthogonal in the discrete form. So what it is? Ex1 plus ex2 plus summation n is equal to minus infinity to infinity xn x2 conjugate n plus summation n is equal to minus infinity to infinity xn conjugate x2n. And this all blah blah blah. We all know that also. Okay, so here comes our first question. So xn half power modulus n is given. So we have to find the energy of this. So what we have to do, we put this xn in the formula. Summation n is equal to minus infinity to infinity modulus xn square is equal to summation n is equal to minus infinity to infinity. We write this 1 upon 2 modulus n whole square. Now what we have seen, because it is square, this 1.2 becomes 1.4. Okay, and so now we have seen that this is even. Okay, how this in this limit minus infinity to infinity goes to here? Yeah, how it goes to here? So what I thought that this is modulus and this is 1.4, so actually it is modulus. So if this is even, okay. So if you put the minus term in this modulus, it will comes out to be positive. So it's always gonna remain positive. So now we will change the limit from 0 to infinity. So when you put 0 in it, you will get 1 upon 4 power 0 as 1. So we write 1 here separately. Now plus from 1 to infinity. Okay. So actually it is even. How we check it is even? Now I get the answer. If you put the even, if you put minus and minus terms in it and positive terms in it, you will get the same answer. So you do remember that the formula in integration, that there is an integration. Let me write. There is an integration minus infinity say infinity uh, a square. Sorry, not a square. X square dx. Okay. So if you put any terms in x minus positive, it will remain positive. So it is an x square, it is an even signal. So we write like this. Uh, cannot see that. Sorry. So we can write it like this. 2 integration from 0 to infinity x square dx. You do remember that, right? But here in summation, we cannot write like this. In summation, so this is minus infinity to infinity. For example, there is x. You have to write. You do not can like this. X add 0 plus summation. This is my summation. Wow. Egyptian summation. Alien form summation. Add 0. If it is 0, okay? No, I have taken the limit. So this is 0. You have to put 0 like this, and not from 1 to infinity x. This is how you write. Okay. Okay. I don't like that. So yeah, hopefully where were we? We were here. Yeah. So we have found that this is even. So we take two outside, and we have some added the value at x is 0. Now if you see this term, okay, this is from a GP. We will write 2 here, and the formula of GP is A upon 1 minus R, like A upon 1 minus R, infinite GP formula. Okay, we will find it after that. So now moving to the second. So my friend, you should do remember that minus 1 to power n. Okay, I messed it up. Oh, actually, I'm trying to learn how to use that. Highlighter. Okay, this is perfect. Okay, this minus 1 to power n is cos n phi. We have to remember that. We will use it in almost time in our upcoming lectures. So now this is Excel in discrete form. 1 upon 2 power modulus n sine n pi by 2. So we have to find the energy of this given discrete figure. So we simply put this Excel in the formula, that is summation n is equal to minus infinity to infinity Excel whole square. So because of that square, this 1.2 will change to 1.4 and this sine will change to sine square. So now sine n pi by sine square and sine square n pi by 2 is 1 minus cos n pi by 2. How? We can relate it by cos 2 theta formula. Okay? Where or simply remember that where this is sine square n pi by 2. Okay? So it is treated. Let me write, then you understand. This is sine pi by 2. So it is like this, sine square theta by 2. So now cos 2 theta is 1 minus, this is my sine, oh my god, sine square theta. So if you change, if you change this, now you can write square theta by 2. So this is how the whole solution comes from. Now we write this value here. Now we see that this term is even. Okay, yeah, so we have seen that that this term is even. So as above, we write 2 outside it and we find value of it at x equal to 0. That is comes out to be 0. Okay, Okay, this comes out to be 0. So, but this sum is optional. If this n is odd, then it is 1. If n is even, then it is 0. So we expand it like simply as we expanded before here. First term is 1 by 2, second term is 1 upon 4 pi cube, third term 1 upon 4 pi 5. Now the r is 1 upon 4 square, and the first term is 1 upon 4. Infinite GP 2 into a upon 1. So this is the answer. Yeah, do you remember this concept that I have tell minus infinity is infinity, so minus infinity is minus 1, plus n infinity is infinity. Okay, and the things are changed in continuous time. Okay, and things are different in discrete times. Okay, now this we are starting the new topic, calculation of average power. So also known as the mean power, mean value or the DC value. So you have to remember that uh, calculation of average power is also known as mean value or DC value. Okay. So first of all, here's one. When xt is non-periodic, so when xt is non-periodic, it is non-periodic. As simple as that. So averages, we, the symbol of that average is we put a dash over xt, so it is called the average of xt. Okay. So now we write, and in the average we have this limit tends to infinity. Okay. Then there is one upon t. So 1 upon t is the symmetrical duration. Okay. 1 upon t integration minus t by 2, say 2 to t by 2 xt. So what is the average is x bar t is equal to limit t tends to 0, 1 upon t integration minus t by 2 to t by 2 xt, where t is the symmetrical duration. Okay. Okay. Now if xt is periodic with a period t, so we write xt is periodic with period t naught. So we write x bar t is equal to 1 upon t naught, that is the periodic time period. Integration limits of the time period xt t. Okay. Now the third case, when xt is non-periodic but it is in the discrete time function. So xn is equal to limit n tends to infinity sigma n is equal to minus capital N by 2 to n by 2 minus 1 xn divided by n. Okay. Do you remember that? We write it somewhere in a sticky notes and then stick besides you, where you can see that formula every day and you can learn it by heart. So yeah, xn is non-periodic, so x bar n and limit n tends to infinity. So summation n is equal to minus capital N by 2 to capital N by 2 minus 1 xn divided by n. So this is xn in non-periodic in discrete form. Now moving forward, when xn is periodic, so it is like 1 upon n naught summation n is equal to 0 to n naught minus 1 xn. These are simply just results that you have to learn by heart, and there is no shortcut. You have to learn that because this is the shortcut. Important results. So if we see two finite duration and finite amplitude, then the average value is 0. So if you see this graph which has this finite duration, okay, and a finite amplitude, that is say here also, so the average value both of the average value of these type of graph is 0. So if you see a graph like this which has a full DC, it is called a full DC. It's from minus infinity to infinity, same value. It is not full DC. Then the average value of this is that same value, that constant amplitude. Okay. So if you see a graph like this, that is for half of the, sometime it is 0, okay, and for sometime it is like a full DC. So it is a half DC. So its average value is a by 2. So if in an exam this graph is given, okay, and we have to find the average value of this graph, we break it into two parts. First part is like this. You can see my cursor. It is like a finite duration, finite amplitude, okay, and the second is like this half DC, okay, and we can simply add them and we get this resultant XT graph. So the average value of the first graph that we have make is average value and average amplitude is 0, and the average value of the second graph, that is half DC, is a by 2. Okay. So now power signal is a new topic. The signal is periodic and non-periodic. Okay. Yeah. Power signal, that is. So I'm going to say in Hindi, power signal when it is not. When you will know that a power signal when it is not non energy, non power. Tan theta. Have you remembered the graph of tan theta? It is like it is periodic and also non energy, non power. So you can say, और उसका एम्पलीट्यूड कहीं पे भी पीरियोडिक नहीं जा रहा है. अगर उसका एम्पलीट्यूड कहीं पे भी पीरियोडिक नहीं जा रहा है तो एन ई एन टी. So now, if this amplitude is finite and this duration is infinite, so we have three conditions for power. Plus, I'm going to say in Hindi, प्लस माइनस पे किसी भी एक जगह एम्पलीट्यूड फाइनाइट मिल जाए. Okay. When t tends to infinity, is gives 0. When t tends to infinity, it does not give 0. Okay. T tends to infinity, it gives 0. T tends to minus infinity, it gives 0. T tends to infinity, T tends to minus infinity, it gives non-zero. T tends to infinity, it gives non-zero. Okay. किसी भी प्लस माइनस की जगह एम्पलीट्यूड फाइनाइट मिल जाए. जैसे इसमें, for example, in this, the first one, here we get amplitude finite at t is equal to minus infinity. Okay, and in this one we get amplitude finite at t is equal to plus infinity, and in this one we get amplitude finite at both t is equal to minus infinity and t is equal to plus infinity. Okay. So case number one, when x is non-zero, so you have to remember that, yeah, power is nothing but it is the average value of modulus x square. Yes. If someone said you have to find the average value of modulus x square, it means he's saying to you find the power of xt. If someone is saying that you have to find the average value of modulus xt square, so actually we have to find the power of xt. So see this, limit t tends to infinity as above, so below. Integration minus t by 2 is like t by 2. Now at the place of xt square we write modulus xt square. Is it xt square? No. Here it is only xt, and here it is modulus xt square. So it is like modulus xt square average value. That is the symmetrical window. Same it is in the periodic one. So the period is 1 upon t. Integration is in the time periodic time limits. Modulus t square is equal to mean square value. MSP means mean square value of xt. Take the mean, square it, and then we get power. Sorry for the sound. So now, as I told you earlier, that this is the the basic uh, energy power formula, power through the energy by time period. Okay, and mg of 1 T naught of xt divided by T naught. So what is energy? Actually, energy is the energy of one time period of xt. So if there is a continuous graph, oh shit. So energy is, it is continuously, this graph is repeating. So energy of this graph is x e x t naught. That is this, and this is time period. Okay. Okay. So as long as we can find energy of one time period, we can use the formula to find power. Okay. So now we starting this power signal. So as we have discussed it earlier, you can see that when xt is non-periodic, so the power is like the mean square value of modulus, or like the average value of modulus xt square, or mean square value of xt. So in average, we write this limit term, limit t tends to infinity, 1 t integration minus t by 6 like t by 2, integration minus t by 2 to t by 2, xt modulus xt square dt. Yeah. So where t is just symmetrical window, and when it is periodic, so you can see that everything is written on the scale. So now when we have to find the power of two signals that we are adding, addition of two signals, and we have to find the power of that signal. So then we're going to write P1 plus P2. Now we write the simple basic formula of power, limit t tends to infinity, 1.2 integration minus t by 2 to t by 2, x1 t x2 conjugate t dt, plus limit t tends to infinity, 1 t integration minus t by 2 to t by 2, x1 conjugate x2 t dt. So here this inside term, okay, is the basic term that we have learned earlier, that for the orthogonal circle. But it is not orthogonal. It is orthogonal only when this integration is zero. Okay? So what you should learn, that in this term, I should take something. Okay? So in power, this limit terms also comes into picture. This limit term. As you know, as we have studied in energy, that we write it simply as E1 plus E2 integration minus infinity to infinity x1 to x2 conjugate plus integration minus infinity to infinity x1 conjugate x2. So here that limit term, that 1 upon t term, okay, that 1 upon t term, and the limits are of the power, or the power that we have done in the power basic formula, and the term we changed and the term inside it is not the right one. So choose like this inside term, okay, this one we have studied in the earlier formula, like in the energy also. So you have to remember that the inside integration term will always remain the same. Okay, this x1t x2 conjugate t dt, x1 conjugate into x2 conjugate t. But the outside term and the limits that I am highlighting right now are come from the power. If you are finding the power, for example, if we are finding, sorry for that sound. So if for example, if you are finding the energy, so if we go up and find formula of energy, can you find it? So here it is the formula of energy. Here you can see there is only limit that taken from the property that are taken from the energy. In the basic energy formula, only this minus infinity to infinity, and the inside of the integration is modulus xt square. Okay? So the inside of the integration will always be x1 and x2 conjugate. Why? Okay, you are telling me why. So please do remember this formula. Modulus of a plus b whole square, and modulus of this is modulus a square plus b square, modulus ab conjugate plus a conjugate b. Okay. Hmm. And the inside term is the same, like in the power. The inside term is same like in the power. So now in the power, formula, if we know that x1 and x2 are orthogonal, then we simply write the expression for power as simply p1x plus p2x. Okay. Now, if this is how you always x2 x3 has a time period of, yeah. This is the uh, this is the formula when x1 and x2 are not orthogonal and are not periodic. And this is the formula when x1 and x2 are not orthogonal and periodic. I think I messed it up. Super. Not periodic and not periodic. And here it is periodic. You can see that. And it is also non-orthogonal. So if we know in this that if both are orthogonal, then simply you can write the power as p1x plus p2x. So here comes the question. If someone gives you like this, this is a full DC. Okay, this is a full DC. Wait. Yes. So what you should do, simply remember that you should take the amplitude of that full DC and take the modulus of that and square it. Don't go to the derivation. You can see, you can take a screenshot and you can find it by yourself. This derivation is done. So now if we have given this graph and we have to find the power of this graph, so we can take the amplitude, that is E plus JQ, and take a modulus of that, modulus of them, and square it. So modulus of p plus j2 square is p square plus c square. Okay, and if you want to find the RMS value, so RMS value is under root of power. So power is p plus q square, so RMS is under root p plus q square. Okay, similarly here. So now, if someone said, what is the power of half DC? So remember that, take the amplitude, okay, and then modulus it, then square it and divide it by 2. That is your half DC power. When, for example, not an example, it's a fact. So when a signal is power, then its energy is infinite. Okay. Now these are the some properties. If xt power is p, then minus ap plus b power is also p. But minus k x minus at plus b power is modulus of minus k square p. So we know that amplitude scaling will change the power. Okay, but if you remember that in the energy, uh, time scaling also changed the power, also changed the energy. So if it is energy, so we can write minus k modulus square into E for energy divided by modulus A if it is energy. But in power, time scaling does not affect, only amplitude scaling affected. Okay, and this is, as I told you, sinusoids power a square by 2, power of periodic signal. So this is the basic uh, formula of power. 1.t integration time period modulus xt square dt, okay, which is equal to et naught upon t naught. So yeah, guys, I want to mention some very uh, um vital, very important difference between non-periodic and periodic. So in the non-periodic, this limit terms, limit t tends to infinity comes into picture. But if you see in the periodic term, when I say periodic, there is no t tends to t limit t tends to infinity term. This is just basic term like other than t tends to infinity. It is simply 1 t naught in integration t naught modulus xt whole square dt, which is the average value of modulus t square or the mean square value of xt. Okay, so do remember that in when it is non-periodic, this limit terms comes into picture, limit t tends to infinity. But if it is periodic, then there is no limit t tends to infinity term. Okay, so here it is the power of periodic signal. So obviously there is no t tends to infinity term in this. Okay, now important is that identify the time period. Okay, and then mark it at t naught, and then find the energy of that time period, and then divide it by t naught. You will find the energy. For example, first of all, we have to check that this is for now. I will be talking in Hindi. That it is lot more easy. Okay. तो इस क्वेश्चन में सबसे पहले हम ये देखेंगे कि इसमें पीरियोडिक है कि ये नहीं है। तो सबसे पहले हम ये देख रहे हैं कि पीरियोडिक है, ठीक, क्योंकि इसमें रिपीटिशन हो रहा है। तो रिपीटिशन किस टर्म का हो रहा है उसको पकड़ो। सबसे पहले जो सबसे छोटा वाला टर्म है उसको पकड़ो। तो ये जो ट्राइंगल और जो रेक्टेंगल है यही रिपीट हो रहा है, उसको पकड़ लिया। ठीक है, अब इसका हम लोग को पकड़ के निकालना है एनर्जी। ठीक है, तो एनर्जी कैसे निकालेंगे, हम लोग इसको दो बार में ब्रेक करेंगे, जो मैंने पहले बताया। ठीक, अब इसमें क्या है कि देखोगे इस ट्रायंगल का हम क्या करते थे कि इसका जो पीक वैल्यू होता था उसका मॉडुलस का स्क्वायर अपॉन डिवाइडेड बाय 3 इनटू इसका टाइम पीरियड जो कि t/2 प्लस ये जो रेक्टेंगल है इसका जो एम्पलीट्यूड है उसका मॉडुलस का स्क्वायर इनटू टाइम पीरियड। ओके, मॉडुलस स्क्वायर है a, टाइम पीरियड का है t/2। तो आ गया एनर्जी। अब इस एनर्जी को तुम टाइम पीरियड टी से डिवाइड कर दोगे तो क्या आ जाएगा, पावर आ जाएगी, तो क्या आएगी 2a² 3 ओके ठीक। सो अब देखो ये बोल रहा है कि यार देखो एक्स टी का पावर ये आई है, तो पूछ रहा है कि एक्स माइनस 3t+2 की पावर क्या होगी। तो हम लोगों ने पहले देख लिया था कि यार जो ये पावर होती है इसमें ये टाइम स्केलिंग का कोई इफेक्ट ही नहीं होता था, इसमें सिर्फ और सिर्फ एम्पलीट्यूड स्केलिंग का इफेक्ट होता है। जो एनर्जी होती है ना इसमें टाइम स्केलिंग और एम्पलीट्यूड स्केलिंग का इफेक्ट पड़ता है, पर यार ये जो पावर होती है इसमें सिर्फ और सिर्फ एम्पलीट्यूड स्केलिंग का इफेक्ट होता है ठीक। जैसे यहाँ देखो बोल रहा है कि बताओ कि पावर ऑफ एक्स 1 - t/t की क्या होगी, क्या वही सेम होगी, क्या आरएमएस वैल्यू ऑफ एक्स 1/t/t की वैल्यू क्या होगी। तो हमें पता आरएमएस वैल्यू जो होती है वो √p की होता है, √ पावर का होता है, तो उसको हम कहेंगे भाई ये होगा इसका अंडरूट ले लो, ये जो यहाँ लिखा हुआ है होगा a/a√2/3 ओके। अब कहेगा पावर ऑफ मॉडुलस xt क्या होगा, ये वही कुछ नहीं होगा, ये होगा सिंपली पावर ऑफ xt जो कि है 2a²/2 2a²/3 ठीक। अब देखो ये वाला टर्म देखो, इसको हमें सबसे पहले क्या देखना है कुछ क्वेश्चन में कि भाई पीरियोडिक है कि नहीं, तो हमने कहा हाँ भाई पीरियोडिक क्या है ठीक। तो अब इसका जो रिपीटिंग टर्म है ना, ये यहाँ से 0 से लेके 2 तक वाला भी होगा उसमें, यहाँ से लेके ये रिपीटिंग टर्म है, तो हम लोग को निकालना है इसका क्या, इसका निकालना है सबसे पहले एनर्जी। यहाँ 0 से 2 तक की एनर्जी क्या है 0 ठीक, 2 से 3 तक की एनर्जी क्या है, देखो ट्राइंगल है, इसका आंसर क्या है 4। तो मॉडल ऑफ 4 का स्क्वायर डिवाइड बाय 3 इंटू टाइम पीरियड कितना है, तो 4² 3 इंटू प्लस ये दूसरा वाला ट्राइंगल है। अब देखो इसका भी हम लोग को क्या निकालना है, एनर्जी निकालना है ठीक। तो इसका एम्पलीट्यूड का स्क्वायर लेंगे, तो ये लिया एम्पलीट्यूड का स्क्वायर है, सॉरी ये इसको पीक वैल्यू कहते हैं, एम्पलीट्यूड नहीं कहते। तो इसका पीक वैल्यू को मॉडुलस का स्क्वायर लेंगे, इसको करेंगे डिवाइड बाय 3, इसका टाइम पीरियड है इंटू 1, तो डिवाइड बाय फिर हो जाएगा इसका टोटल का टाइम पीरियड। देखो ध्यान से, you have to see very carefully that the time period of this is from 0 to 4. The first time when I solved this question, I have taken from 2 to 4, so I have written 2, so by which I get the wrong answer. But actually, this repeating term is also including 0 to 2 term. Okay, so the time period is from 0 to 2, so time period is 4. Okay, so the power comes out to be 8/3 watt. Okay, and if someone say to you find the RMS value, so you can underroot the power and you can find the RMS value which is underroot 8/3. Okay, दूसरे क्वेश्चन में देखो क्या है कि ये अब सबसे पहले इसको देख के हम लोग को जानना है कि हाँ क्या ये पीरियोडिक है कि नहीं। हाँ तो पीरियोडिक तो भाई है ठीक। अब देखना है कि सबसे जो छोटी जो लिमिट है जो रिपीट कर रही है इसको पकड़ता है। ये मैंने पकड़ा कि भाई ये जो गोला है और ये जो ये नीचे ट्राइंगल है ये रिपीट कर रहा है, तो अब मुझे इसकी एनर्जी निकालनी होगी एक टाइम पीरियड की, और इसको टी से डिवाइड कर दूंगा तो मेरे को तो पावर मिल जाएगा। तो इसको मैंने 2 बार में डिवाइड किया, मैंने इसको कहा कि यार ये आधा साइनसॉइडल है और ये आधा ट्राइंगल है, तो मैं साइनसॉइडल का पहले से भाई मैं या फिर करके आया हूँ पहले से क्या होता है क्या। तो अब इसमें देखो इसको कैसे सॉल्व किया गया है, ये देखो इसने लिखा ए साइन ओमेगा टी। अब देखो इसमें कंडीशन ये दी गई है कि 0 से t/2 है, देखो उसने टाइम पीरियड दिया हुआ है। तो मैंने देखो पिछले में क्या याद करवाया था कि जो टाइम पीरियड होता है वो n/f0 n/4f0 के फॉर्म में होना चाहिए, समझे, तब जाके वो ये हम लोग ये वाला लगा सकते हैं ठीक, a²/2 वाला। उसके लिए चेक करना होगा कि यार ये वैलिड कर रहा है कि नहीं कर रहा है ठीक है। तो क्या करेंगे, ए साइन ओमेगा टी लिखा है, ये पूरा ये है 0 से t में, एनर्जी है a²/2 इंटू टाइम पीरियड व्हेन t इज n/4f ठीक। तो यहाँ लिखा कि 0 से t/2 है। तो देखो ये वाला फॉर्मूला में पढ़ के आए ठीक है, जब भाई 0 से t रहेगा तो तुम कर देना a²/2 इंटू टी, ये तुम्हारा हो जाता है भाई क्या एनर्जी ठीक है। तो और अगर तुमको टाइम पीरियड क्या दिया हुआ है तुम्हें 0 से t/2, तो जब तुमको 0 से t/2 दिया हुआ है टाइम पीरियड, तो तुम्हारा एनर्जी अब क्या हो जाएगा, तुम्हारा एनर्जी अब हो जाएगा a²/2 इंटू t/2 ठीक है। तो अब तुम क्या लिखोगे, समझ रहे हो क्या कह रहे हैं, देखो फिर से हम पढ़ के आए थे भाई ये, यहाँ पे था टी ए इतना ही, तो टी ए एडिटिव आ गया और इसको हम डिवाइड कर देते टी से टी कट जाता था तो पावर आ जाती थी अपनी मस्त मस्त ए स्क्वायर बाई टू। और यहाँ पे क्या मामला चल रहा है, यहाँ पे इसने हमने को लिमिट दे दी है और उसने लिमिट कर दी चेंज, फिर कर दी टी बाई टू। तो यहाँ भाई ने जो मैं पढ़ के आए थे उसने किया है टी और उसने कर दिया टी बाई टू। तो अब ये एनर्जी हो जाएगी हमारी ए स्क्वायर बाई टू इंटू टी बाई टू। तो यहाँ जब पावर लिखोगे तो इसका हो जाएगा ए स्क्वायर बाई टू टी बाई टू। ठीक, समझे, इतने पार्ट प्लस ये ट्राइंगल और ये छोटा सा पार्ट, ये ध्यान से रखो, ये टू टू टी बाई थ्री से लेके टी तक ये टर्म दिया है। ठीक है, हिंदी बोलने में बहुत जोर लग रहा है तो जल्दी में थक रहा है, इंग्लिश में इतना दिक्कत नहीं है। तो अब देखो यहाँ का लिया मॉडुलस का ए स्क्वायर बाय थ्री, मॉडुलस में पीक वैल्यू है, पीक वैल्यू का ये है ए स्क्वायर एक स्क्वायर बाय थ्री इनटू टाइप होता है टू टू टी बाई थ्री माइनस टी बाई टू, तो है टी बाई सिक्स प्लस यहाँ पर इसका एम्पलीट्यूड है जीरो का स्क्वायर इंटू दिस, ये आ जाएगा, ये आ गया हमारा भाई क्या एनर्जी, सॉरी पावर आ गई, नीचे टाइम पीरियड भी था। तो एक्स टी की पावर ये है, तो माइनस टू टी प्लस वन की पावर क्या होगी भाई, सेम वही रहेगी, तो आपको पता है भाई टाइम स्केलिंग नहीं हो सकता। तो देखो यहाँ पे माइनस थ्री दे दिया है, तो मॉडुलस ऑफ माइनस थ्री के स्क्वायर से इंटू कर देंगे इसको, तो याद है। आर में से पूछेगा भाई तो क्या करेंगे, अंडर रूट ले लेंगे। ठीक है, हाँ। सो अब ये जो क्वेश्चन है इसको देखते हैं कि इसमें पहले दिया हुआ है एक्स टी है, एक एरर के बाद पावर निकाल, तो मैं क्या करूँगा इसमें दो पार्ट में डिवाइड करूँगा। एक जो मेरा कर्सर देखते रहो यहाँ से ये, ठीक, मैं वैसे बना ही लेता हूँ समझ में, ठीक से करूँगा दो पे था शायद, दो पे साइड करो, तो ये यहाँ से लेके देखिए, ठीक, ये बना है और एक ये बना है। तो मैं बना था, अब मैं देखता कि यार ये जो है, अब मैं इस वाले टर्म को, जो ये टर्म है इसको मल्टीप्लाई करता है इससे तो जीरो आ जाता है, ठीक, और फिर इस वाली टर्म को मल्टीप्लाई करता है इससे तो भी जीरो आ जाता है ना। तो फिर मॉर्निंग से देखो ये हो गया था, ठीक है। इसमें क्या है कि ये ग्राफ को हम लोग को पावर, तो इसमें दूंगा सबसे पहले कि मैं इसे दो पार्ट में इसको डिवाइड करूँ, पहले ये एक पहला पार्ट, ये दूसरा पार्ट, ठीक है, ठीक, पहला और दूसरा, ठीक है। उसके बाद मैं देखूंगा कि यार ये पहला वाला ये तो पावर पावर सिग्नल है, इनफाइनाइट पे देखो एम्पलीट्यूड सेम दे रहा है, इनफाइनाइट पे नॉट इक्वल टू जीरो वैल्यू है। ये वाला जो है ये एनर्जी है, एनर्जी क्या होता है, तो फाइनाइट ड्यूरेशन फाइनाइट एम्पलीट्यूड, या फिर अगर इनफाइनाइट ड्यूरेशन है तो इन्फिनिटी पे एम्पलीट्यूड फाइनाइट है, तो यहाँ से देख सकते हो फाइनाइट है। तो हम लोग को पता है अगर हम लोग इसकी पावर निकालेंगे तो इसका पावर तो जीरो हो जाएगा, क्योंकि एनर्जी का सिग्नल का पावर जीरो होता है, तो यहाँ जीरो लिखा। अब इसको ध्यान से कि ये हाफ डी सी है, ठीक है, हाफ डी सी की पावर क्या होती है, ये इसका स्क्वायर, ये एम्पलीट्यूड का स्क्वायर बाय टू, तो डायरेक्ट ऐसे हम लिख सकते हैं। तो हम लोग ये भी ध्यान रखेंगे कि प्रॉपर्टी जो होती है ना एनर्जी की, पावर सिग्नल की, उन सबको भी माइंड में रखेंगे, और छोटे छोटे फॉर्मूले होते हैं, हाफ डी सी फुल डी सी डायरेक्ट, इससे हो जाए, वैसे देखने में बड़ा डेंजर लग रहा है। अब फिर कर्सर दिख रहा होगा, तो वी आर स्टार्टिंग, focus on my cursor, all right, okay, Now we starting this topic, discrete time power signal. हाँ, तो देखो इंग्लिश है। देखो इसमें जब पहले ये डिस्क्रीट है, हम लोग ने कॉन्टिन्यूस पहले ऊपर देख चुके हैं, ठीक। तो ये कह रहा है एक्शन है, तो इसमें हम लोग को पावर का ही फॉर्मूला याद करना है। कैसे है देखते हैं कि अब देखो जब ये नॉन पीरियोडिक होता है ना, मैंने पहले बताया था उसमें नॉन पीरियोडिक वाले में यार लिमिट वाली टर्म आती है, और यहाँ देखो जब पीरियोडिक है तो यहाँ कोई लिमिट वाली टर्म आ रही है, ठीक है। नॉन पीरियोडिक है तो लिमिट एन टेंस टू इंफिनिटी 1/2n+1 सिग्मा n इक्वल टू माइनस एन से एन मॉडुलस एक्स एन होल स्क्वायर, ठीक है। पावर हमारी यहाँ मॉडुलस एक्स एन क्यों आया, क्योंकि पावर हमारी क्या होती है, ये एक तरह का एवरेज वैल्यू निकाल रहे हैं हम लोग डिस्क्रीट में, और हम लोग एवरेज वैल्यू निकाल रहे हैं मॉडुलस एक्स एन स्क्वायर का। तो जो पावर होती है वो होती है मॉडुलस एक्स स्क्वायर का एवरेज, ठीक है। अब यहाँ पे आ जाओ, पीरियोडिक में क्या होगा, अगर पीरियड एन नॉट है इसका, मतलब एन नॉट सैंपल्स इसके रिपीट हो रहे हैं डिस्क्रीट में, तो फिर यहाँ लिखेंगे, अब लिमिट हटा दो, 1/n0, ठीक। अब यहाँ पे सिग्मा n इक्वल टू 0 से लेके एन इक्वल एन नॉट -1 तक, ठीक है। एन नॉट है इसकी पीरियोडिक। अब यहाँ पे अंदर मॉडुलस एक्स एन स्क्वायर, ठीक। अब ये जो होता है पीरियोडिक वाला, ये हम लोग ने ऊपर पढ़ा था, ये होता है अ, ये डिस्क्रीट है, इसलिए ई एन नॉट अपॉन एन नॉट। अगर जैसे मान लो ये टाइम होता तो यहाँ पे एन की जगह लिखते टी। अगर ये टाइम डोमेन में होता तो यहाँ ये तो सही है, ई टी लिखते हैं, यहाँ जो है यहाँ पे ये यहाँ लिख देता हम लोग टी, ठीक है। ओके, ठीक है। उसके बाद अब क्या करते हैं यहाँ, ठीक है। अब लिखा हुआ है म्यूचुअली कौन से जुड़े हुए हैं, सब पता है पहले से, डायरेक्ट P1 PX1 PX2 ऐसे ऐड कर सकते हैं, ठीक है। तो देखते हैं, ये क्वेश्चन है। तो यहाँ पे अब देखो हम लोग क्या दिया गया, एक्चुअली मैं भी तुम्हारे साथ ही पहली बार ये पढ़ रहा हूँ, तो आगे रिवाइज कर रहा हूँ, तो मेरे साथ थोड़ा सा फोकस करना। क्वेश्चन दिया है हम लोग को ए की पावर ए इंटू 1 की पावर एन। 1 की पावर एन इसलिए होता है क्योंकि 1 1 1 1 होता है। 1 की पावर एन का जो तुम्हारा ये होता है ना, ये ऐसे होता है, ये ऐसे, यहाँ पे 1 1 1 1 1 1 1 ऐसे करके होता है, ठीक है। तो ये इसलिए है कि हम लोग इसमें कोई भी कांस्टेंट वैल्यू ऐड कर सकते हैं। यहाँ ऐसे 1 1 होता है, यहाँ पे ए ऐड किया तो यहाँ ए ऐसे आता है, ठीक। और तो अब हम लोग को ये सिर्फ सिंपली दे दिया कि निकालो भाई, तो हम लोग ने ऐसे ग्राफ बना लिया। अब ग्राफ ऐसे बना लिया, कुछ वो नहीं है, पावर उसमें रखा हम लोग ने फॉर्मूले में। तो सबसे पहले मैंने देखा इसको कि यानी पीरियोडिक है, ठीक है। पीरियोडिक है तो मैं समझ गया कि ये वाला फॉर्मूला लगेगा यहाँ पे, ठीक। जैसे क्या है 1/n0 सिग्मा n इक्वल टू 0 एन नॉट -1 मॉडुलस एक्स स्क्वायर, ठीक। अब यहाँ पे क्या कर रहे हैं, देखिए देखिए, हाँ। हम्म, तो यहाँ से एक फॉर्मूला प्रूव कर रहे हैं, ठीक है, ये वाला फॉर्मूला है। तो मैं उस पर नहीं जा रहा, ठीक है, उस पर यहाँ डायरेक्ट है। फॉर्मूला भी नहीं, ये देखो यहाँ कुछ सिग्मा ए से बी 1 है, तो इसमें क्या होता है, अपर लिमिट लोअर लिमिट, हाँ, बी -a+, ऐसा होता है। और माइनस लोअर +1, इसमें ए है 1 है ए है, तो यहाँ अपर माइनस लोअर +1, ठीक। अपर माइनस लोअर +1 ऐसा रहता है सैंपल है एन नॉट 1 है, वो देख रहे हो ना, 1 1 1 पे रिपीट कर रहा है। तो जो मिनिमम सैंपल है इसको जो रिपीट कर रहा है वो है हमारे 1। तो एन नॉट को 1 लग दिया, तो ये एन नॉट आया, तो ये सिग्मा, ये 0 हो गया, ठीक। यहाँ पे देखो ये 0 हो गया, 0 0 ये 1। और इसका क्या होगा, ए स्क्वायर अपॉन ये नॉट ए से ये आ गया, 0 से 0 1, तो अपर माइनस लोअर +1, तो इसका 1 आएगा, तो इस पर 1 तो 1। इंटीग्रेशन में ऐसे में क्या होता था कि यहाँ से जीरो आता था, टाइम टाइम डोमेन में जीरो आता था, यहाँ पे ऐसा नहीं होगा। ठीक है, तो कह रहा है कि यहाँ पे ये दिया हुआ है e की पावर j ओमेगा नॉट, ठीक है, ये पीरियोडिक नॉन पीरियोडिक, तो मतलब ये पता नहीं है क्या। तो देखो पहले ये हम लोग नॉन पीरियोडिक वाला लिख रहे हैं, लिमिट एन टेंस टू इनफिनिटी 1.2n प्लस 1 सिग्मा n इक्वल टू माइनस एन से एन मॉडुलस एक्स एन स्क्वायर। ठीक है, मॉडुलस एक्स एन यहाँ पे मॉडुलस ए है। अब फिर यहाँ पे एक्स लिमिट एन टेंस टू इनफिनिटी 1.2n एन स्क्वायर। ठीक है, अच्छा यही है, ठीक है, यही है, ठीक है, ये वाला दिया हुआ है, ये जो है ये वाला यही यूज हो रहा है जी, नीचे भी। तो यहाँ पे मॉडुलस मॉडुलस एक्स एन स्क्वायर है ना, ए स्क्वायर हो जाएगा, तो इसका बाहर आ जाएगा, तो नीचे आ जाएगा, अंदर आ जाएगा वन, वन आ जाएगा, जिसका क्या होगा एन माइनस माइनस एन प्लस वन, ये टू एन प्लस वन हो जाएगा, तो टू एन प्लस वन आ गया, तो नीचे टू एन प्लस वन पहले से था, तो ये कट जाएगा, तो ए स्क्वायर आ जाएगा। अब बोला है मैंने यहाँ लिखा होगा नोट्स में, मैंने ऐसे करके लिखा हुआ है मैंने कि दिस इज जनरल फॉर्म इफ वी अप्लाइड इट इन पीरियोडिक फॉर्म देन आल्सो वी गेट द सेम आंसर। अच्छा ये वाला जो फॉर्मूला है ना, जो नॉन पीरियोडिक वाला जो हमने लिखे हैं, ये एक्चुअल में इतना, ये एक तरह का जनरल फॉर्म है। अगर कोई तुम्हारा पीरियोडिक सिग्नल भी है ना, अगर उसमें भी लगाओगे तो भी तुमको आंसर देगा, पर प्रिफर जो अलग फॉर्मूला है वही करना। तो इस पे आ जाते हैं पावर ऑफ साइनसॉइड सिग्नल्स पे। पहले हम देखो, जैसे इसका हम लोग को निकालना है ए कॉस ओमेगा नॉट प्लस फाइव, तो इसका पावर क्या हो जाएगा ए स्क्वायर बाई टू। ठीक, पहले ही बता चुके हैं, कोई नहीं बात नहीं। आर में से तो बस याद रखो कि अंडर रूट और पावर होता है, तो ए अपॉन रूट टू है, ठीक है। इस वाले का देखते हैं, ए स्क्वायर ओमेगा, देख लो क्या मुझसे बोलना है, इसमें बस ये लिखा हुआ है कि ओमेगा वन इज नॉट इक्वल टू ओमेगा टू, ठीक है, तो मतलब ये फ्री है, ओमेगा फाइव ओमेगा टू फ्री है। तो अगर ये दोनों ओमेगा वन ओमेगा टू इक्वल नहीं है, तो मतलब क्या है ये, मतलब ये है ये दोनों ऑर्थोगोनल, ठीक है, ऑर्थोगोनल होते हैं ना, तो डायरेक्टली पी वन प्लस पी टू करके हम लिख सकते हैं। ठीक, तो इसका क्या हो जाएगा ए स्क्वायर बाई टू, इसका क्या हो जाएगा वही बी स्क्वायर बाई टू। ठीक, पहले आ जाओ इस वाले में देखो, ए स्क्वायर ये है, इसमें बोला है कि फाइव वन फाइव टू इक्वल है, ठीक है, तो हम लोग को याद है कि जब इक्वल होते हैं तो मतलब डायरेक्टली ये नहीं जंप करेंगे कि ये नॉन पीरियोडिक है, इनके डेल्टा के एंगल के बीच का वो भी देखेंगे क्या देते हैं। अगर वो इस टर्म में होता है, इन दोनों का डिफरेंस अगर टू एन प्लस वन फाइव बाई टू में होता है, जैसे फॉर एग्जाम्पल वन रखते हैं, रखा जीरो रखो, जीरो जीरो रखा तो फाइव बाई टू, वन रखा थ्री फाइव बाई टू, ठीक है, टू रखा क्या होगा फोर फाइव फाइव बाई टू। हाँ, अगर उनका डिफरेंस ना फाइव बाई टू का मल्टीपल है ना, तो वो होंगे ऑर्थोगोनल, ठीक है। तो हम लोग फिर से डायरेक्टली ऐसे टी वन प्लस टी टू लिख सकते हैं, ए स्क्वायर बाई टू और बी स्क्वायर बाई टू, ठीक। तो यहाँ पे ये एक्स वन है, ये एक्स टू है, और ये बोल दिया भाई इसने कि एक्स वन जो एक्स टू है नॉन ऑर्थोगोनल, ठीक है। अब क्या होगा, ये करवाया नहीं डिफरेंस, बोले थे कि जॉब में करवा के आओ, तो ना तो रख लिए थे भाई, ये वाला तो देखो पहले वही सिंपल देखो पी वन प्लस पी टू प्लस वो वाला टर्म नहीं होता था जो आता था उधर टाइम में, उससे वो वाले में इंटीग्रेशन माइनस इनफिनिटी से इनफिनिटी एक्स वन एक्स वन एक्स टू कॉन्जुगेट, तो दूसरे वाले में एक्स वन कॉन्जुगेट एक्स टू, ऐसा वाले का फिर। तो इसमें ये है, याद रखो कि ए बी कॉस फाइव वन माइनस फाइव इसका था, बाकी एज इट इज वाला पहले था। अब मान लो इतना बड़ा सा कोई वेरिएबल तो करेंगे, कोई कांस्टेंट है तो फुल डीसी मान लो, फुल डीसी होता है तो कांस्टेंट पड़ा था, तो फुल डीसी की पावर क्या होती थी, भाई ये आएगा, ये रहेगा एक्सेस, ये मान लो ऐसे था, ये था इसका ए, ऐसा होता था ना यार, ए स्क्वायर होता था है, और एक ऐसे होता था, तो यहाँ पे जीरो जीरो जीरो, फिर यहाँ से ऐसा, इसका ये भी ए है, ठीक है। ये था ए स्क्वायर बाय 2। तो ये हमको याद रखना होगा, रिलेट करने का। कहीं पे उल्टी सी बोलेगा, कहीं पे नहीं बोलेगा। कहीं डायरेक्ट कॉन्सेप्ट हम देगा तो उनको पता लगाना होगा। तो उसमें कोई बड़ी बात नहीं है, मिटाने में पड़ जाए। तो देखो, पहला वाला कांस्टेंट है तो उसका सिंपली आर नॉट स्क्वायर कर दो। दूसरा वाला देखो साइनसॉइडल है, तो अभी हम ऊपर पढ़ गए हैं कि ये मॉडुलस का स्क्वायर बाय 2 होता है। ये मान के चले, देखो जैसे बोला है इनिशियली ऑर्थोगोनल है ना। और देखो पीरियोडिक भी तो बोला गया इन द टाइम पीरियड ऑफ 0 to 2 पाई का ओमेगा, ठीक। तो आर में से होगी तो रूट रूट लेगी। यहाँ पे भाई आपको कॉजल, नॉन कॉजल एंड एंटी कॉजल, मेरे दोस्त का नाम कौशल है तो मैं उसे कौशल, नॉन कौशल और एंटी कौशल बुलाते हैं। कॉजल में से निकल रहा है, कौशल सिग्नल हम बोल रहे हैं, मैं हम कौशल, एक्स नॉट जीरो है, t is less than zero, or for discrete also, n is less than zero and n is less than equal to minus। हाँ, तो इसमें देखो ये है, डिस्क्रीट अलग होता है, हो जाएगा अभी, आगे आ जाएगा। अभी बस इसको देख लो कि ग्राफ आएंगे आएंगे तो इससे तुम समझ जाओ। यू टी है, यू टी माइनस टू है, यू एन है, यू एन माइनस टू है। तो इसमें जो पार्ट ऑफ ग्राफ फॉर नेगेटिव वैल्यू ऑफ टाइम है जीरो। जो नेगेटिव है पीछे वाला वो जीरो, ठीक है। तुम्हारा आ जाता है आगे नॉन कॉजल सिग्नल। नॉन कॉजल सिग्नल सिंपली होता है विच इज नॉट कॉजल। जो भाई नॉन कॉजल नहीं होता, ठीक? तो ये देखो ये भी, ये आगे से शुरू हो रहा है पॉजिटिव से, ठीक है। कॉजल का मेन डेफिनेशन ये था कि जो नेगेटिव एक्सिस है ना वहाँ पे जीरो है, और बस पॉजिटिव एक्सिस पे रहे जो भी ग्राफ बन रहा है, ठीक है। तो ये तो कॉजल है। अब इसकी बेसिक डेफिनेशन कोई फेल कर रहा है, ये यहाँ पे है तो ये नॉन कॉजल है, ठीक है। अब एंटी कॉजल एट ग्रेटर देन इक्वल टू जीरो पे जीरो रहे। अच्छा, आगे जीरो है तो ये कहना चाहता है कि ये जो पॉजिटिव वाला है ना यहाँ पे, यहाँ जीरो रहे, यहाँ पे जो जो भांगड़ा हो से सफा कर होता है, यहाँ पे से जीरो रहना चाहिए, ठीक। तो ग्राफ शुड बी जीरो फॉर पॉजिटिव वैल्यू ऑफ टाइम इंक्लूडिंग जीरो। अच्छा, ठीक ठीक। अब देखो इसमें देखो, ये कॉजल है, ठीक, ये कॉजल है, ठीक, ये नॉन कॉजल। तो ये दो, ठीक है, ऐसे तो करके पहला हो गया। यू माइनस टी जो होता है वो यू माइनस वन का एनालॉग होता है ना। ये वाला यहाँ ऐसे लिखा हुआ है, ये ऐसे शुरू होगा। ये अभी ये नहीं जोड़ा होगा, और ये वाला जो होगा ये भी जोड़ लेगा पहला जीरो में। तो फिर इसके बाद जो एंटी कॉजल है ना वो जीरो को भी इंक्लूड कर लेता है, तो जीरो इंक्लूड कर लिया है, और पॉजिटिव में जीरो है, नेगेटिव पे वैल्यू है वो भी है, तो इसलिए एंटी कॉजल है। कॉजल इज नॉन कॉजल बट नॉन कॉजल इज नॉन। ये बड़ी टर्म यूज होंगे आगे इसको बताना कुछ नहीं। अच्छा, ये टाइम फॉर्म में कुछ फाइनाइट है किसी का एरिया तो उसे कहेंगे, अगर फाइनाइट एरिया तो कहेंगे इंटीग्रेबल। अगर एरिया, अगर उसके मॉडुलस का एरिया फाइनाइट है ना तो कहेंगे एब्सोल्युटली इंटीग्रेबल। वही इसमें या वो डिस्क्रीट में अगर उसका फाइनाइट एरिया है किसी का तो कहेंगे उसको समेबल। और अगर मान लो इसका मॉडुलस का फाइनाइट एरिया है तो उसे कहेंगे एब्सोल्युटली समेबल। क्योंकि डिस्क्रीट में तो हम लोग ऐड करते हैं, मतलब ये कह रहा है ये डेल्टा है तो डेल्टा का एरिया फाइनाइट होता है, टी फॉर्म में हम लोगों ने पढ़ा था। तो ये एब्सोल्युटली कन्वर्टेबल। हाँ, तो ये जो है ना, ये एब्सोल्युटली इंटीग्रेबल है। ठीक है, ये एब्सोल्युटली इंटीग्रेबल है, एरिया है फाइनाइट, इसके मॉडुलस का एरिया है फाइनाइट। ठीक है, अब देखो एक चीज होती है भाई कि स्टेबल सिग्नल, सिग्नल कभी स्टेबल और अनस्टेबल नहीं हो सकता। इसको, इससे वाहियात क्वेश्चन हो नहीं सकता। ठीक है, ये हमारे सब बोले सिस्टम होता है ना, सिग्नल स्टेबल, सिग्नल एक्चुअली कभी स्टेबल नहीं होता। ठीक, इससे कोई वाहियात क्वेश्चन होगा। स्टेबल तुम्हारा सिस्टम होता है, सिग्नल नहीं कभी स्टेबल होता है। ऐसे बोलते हैं, बोल चाल से होता है, तो याद है। देख लो, इस वाले को देखिए, हाँ एब्सोल्युटली समझ बाउंडेड, बाउंडेड एंड अनबाउंडेड हैव नो कोरिलेशन विद एब्सोल्युटली इंटीग्रेबल और एब्सोल्युटली सेपरेबल। कोई रिलेशन नहीं है बाउंडेड और अनबाउंडेड का। ये नहीं कि अगर वो एब्सोल्युटली सेपरेबल है बाउंडेड होगा, अनबाउंडेड कोई रिलेशन नहीं है। ये एकदम अलग प्रॉपर्टी है। तो इस वाले सबसे पहले हम लोग ने एक्सट्रीम बाउंडेड, तो मॉडुलस ऑफ एक्सट्रीम इज लेस देन इक्वल टू एम, एंड एम इज लेस देन इक्वल टू इन्फिनिटी। एम मान लो फाइनाइट है, ये टाइम फॉर्म में हो गया। अब हम लोग ने डिस्क्रीट फॉर्म में क्या करेंगे कि मॉडुलस, मॉडुलस एक्स एन इज लेस देन इक्वल टू एन इज लेस देन इन्फिनिटी, ये फाइनाइट है। और ये बीच का है कि माइनस इन्फिनिटी से लेके इन्फिनिटी के बीच में है, जो ये नाइन होना चाहिए। एन फॉर यहाँ डिस्क्रीट रिप्रेजेंट। एक अब बेसिक यहाँ ये है कि जैसे ये ग्राफ दिया है, पूछा है बाउंडेड है, मान ली पूछे कि बाउंडेड है कि नहीं बताओ, ये वाला दे दे पूछे कि भाई बाउंडेड है कि नहीं बताओ। ठीक, तो क्या करोगे, अगर कि बोला कि कहीं पे भी, कहीं पे भी अगर सिग्नल इन्फिनिटी नहीं है तो बाउंडेड सिग्नल हो गए। अब ये देखो, ये जो ग्राफ है कहीं पे भी इन्फिनिटी नहीं है, इसकी वैल्यू कहीं पे भी इन्फिनिटी है ही नहीं, तो ये बाउंडेड सिग्नल कहलाएगा। देख रहा हूँ खुला है यहाँ पे, हवा नहीं हो गया और ऐसा नहीं है, ये है बाउंडेड सिग्नल। अब यहाँ भी देखो ऐसे लग रहा होगा ये चला जाएगा इन्फिनिटी पर, ये कहीं पे भी इन्फिनाइट नहीं टच कर रहा है। ठीक है, तो ये भी बाउंडेड सिग्नल ही होगा। ऑल्दो लग रहा होगा कि ये होना तो शायद अनबाउंडेड चाहिए, तो ये बाउंडेड, ये कुछ बाउंडेड सिग्नल है उसको। वैसे भी तो ऑन टिप्स याद कर लो, फायदा ही रहता है। सामान बता रहे हैं, ये निकल देखो साइन। ठीक है, बाउंडेड, सिग्नम टी बाउंडेड, ओके, यूनिट स्टेप बाउंडेड, डीसी कांस्टेंट बाउंडेड, ई के पास हाफ बाउंडेड, ऐसे रहते हैं। इस वाले को बताते हैं, कुछ ऐसे रहता है, ऐसे करके ऐसे, ये वाले का। ठीक है, पहले बताता हूँ डेल एन, डेल एन का बाउंडेड। अनबाउंडेड देखो किस टाइप का रहता है, सिग्नम टी। ठीक है, उसका इन्फानाइट पे जाता है ना वैल्यू, वैल्यू इन्फानाइट पे टच करती है, पर जो एरिया होता है वन होता है, आर टी रैम फंक्शन का। हाँ, अब इन दोनों को प्लस करोगे तो आ जाएगा तुम लोगों को, तो अलग अलग में ये दोनों अनबाउंडेड है। लॉग एल एन टी का भाई ऐसे ग्राफ होता है कुछ, ऐसे करके कुछ होता है, तो भी इन्फानाइट जाता है, और एन टी भी इन्फानाइट जाता है। Hello, is my voice is audible? Okay, so we are starting now. Okay, so we have already covered that what is orthogonal quantity. Any quantity which has the inner product preceding it is called orthogonal. So now we are going to show you what is orthogonal trigonometry. The two signals x1 and x2 are orthogonal if and only if their inner product is 0. Okay? Yes. So here is x1 and x2 are continuous time signals. And x1 and x2 should be non-periodic signals. Okay? So this integration minus infinity to infinity x1t x2 conjugate dt is equal to 0. So the bottom line is this, that we want this integration to be 0. Okay? It doesn't matter that, see here, when x1 x product x2 conjugate is not 0, but the integration minus infinity to infinity x1t into x2 conjugate is 0. So that is the bottom line that we want, the integration to be 0. Okay? Against to when the x1 x2 are continuous time signal and x1 and x2 are periodic with a common t. So as you know that when it is when x1 x2 are not periodic, then we use the limit minus infinity to infinity, and when x1 and x2 are periodic, then we uses the periodic time period. Okay, integration to that. Okay, and in the discrete time when x1 and x1n and x2n in discrete time and x1 and x2 are non-periodic. So again in discrete time we use summation n is equal to minus infinity to infinity, and this is the condition that should be valid. Okay, the bottom line is that this condition, whole condition, this summation should equal to 0. Okay, now again when x1 n and x2 n are periodic with a common time period n naught, so summation n is equal to capital N naught, and x1 n into x2 n conjugate is equal to 0. So this is set of mutually orthogonal signal. Okay, so example I is equal to sine t, okay, and j is equal to sine t. So when I is equal to j, and when I is equal to cos t and j is equal to sine t, then I is not equal to j. Where this is I is equal to j means I is equal to sine t and j is also sine t. Okay, so I is equal to j, when I is equal to cos t and j is equal to sine t, then I is not equal to j. So when they when they are not equal, it is 0, and when they are same, it will not be 0 value. Same with this discrete signal. Okay, the set of also signal. Okay. A set of mutually orthonormal signal. Sorry, earlier I have said orthogonal signal. It is orthonormal signal. Okay, so when x1t x2t up to xk will be okay. Xn is a set of an orthonormal signal. Okay, this is normal. U2 and U minus T orthogonal. How to check their orthogonal? Okay, so integration minus infinity to infinity dt into U minus T conjugate dt. So signal Okay, any signal conjugate gives the same signal. Okay, so we write at the place of u minus t conjugate u minus t. So ut into u minus t is 0. So this integration value is 0. So we can say that it is orthogonal. Okay. So now with this data u1 and u minus n, so it is non-orthogonal. Why? We use this formula sigma n is equal to minus infinity to infinity un u conjugate minus n. So again the series conjugate doesn't change the series, conjugate doesn't change the series, so we write u minus n at the place of u minus n conjugate, and un and u minus n conjugate gives us del n in discrete. So it is not, it will give us the value of 1 and it is not equal to 0. So it is not orthogonal. These are all examples. Okay, this is the function. This time period is 2 pi by omega. And this is the function. This time period is 2 pi by omega. Okay, the time period for both of these functions x1 and x2 are 2 pi by omega. So we use the integration as 0 to 2 pi by omega. Okay, now we write the first x1 here e for j omega naught t, and this is x2 e for minus j omega naught t conjugate. Okay, dt. Now the conjugate will change the sign of this imaginary part, and this both get added. So e to the power 2 j omega naught t dt. Now we know that e to the power 2 j omega naught dt is cos 2 omega naught plus j sin 2 omega naught. Okay? So we break the cos part and sin part apart, and it limits separately. Okay, and as you remember that we have learned these integration above. Let me show you. Okay, yeah, this is the integration that we are using in the question below. This is 0 to 2 power minus sin omega t dt is 0 to 2 power minus cos omega t dt is 0. Okay, so do remember all of the above integration that are very useful for us in the future. Okay, so it will give us the value 0 plus 0 0. Okay, now moving forward, we have to check that this signal, this sawtooth signal, is orthogonal or not. So this is a x1 graph and this is a x2 conjugate graph, which is, this conjugate does not change the symmetry of the graph. Okay, the nature, does not change the nature of the graph, so it will remain as this, and we can call it simply as x2. Okay, so now we have to multiply it. So watch carefully. This is plus 1. See where my cursor is. Okay, so this is plus 1. Step change, and this is a RAM, and this hole is, you can call as sort. This will this signal into 1 with this. Now at minus 2 now there is a degrees of minus 2. Okay, there are degrees of minus 2. So up to minus 2 we get this, and here we have minus n and this minus 1. This is minus 1. Okay, no, this is minus 1 and this is another circle. So it will change its shape. Okay, it will be drawn like this in the opposite direction. So this is the basic uh, structure of this waveform. Now it will repeat itself. We can copy it like that. Okay, so now we have to check this resultant graph. That integration of minus that it is an periodic graph. So we use an integration 0 to 2 to not x1 x2 conjugate and is it 0. So yeah, this is plus q, this is minus q. So it is 0, so this is orthogonal. So there is a property that segment of the different signals in orthogonal part. This is a waveform. So this waveform has different segments. For example, like this is the circle, this is a triangle, this is a square, again this is a circle. Okay, so we can break this waveform into different segments. Now, if you multiply each of the segments, this circle will multiply with this zero, this triangle will multiply with this zero, this triangle will multiply with this zero, this square will multiply with this zero, this square will multiply with this zero, this square will multiply with this zero, this circle will multiply with zero, zero, zero. So segmentation given segment into orthogonal. So all of these x1, x1, x2, x2, x4 are set of orthogonals. So we cannot say these are the orthogonal because if you break them into two parts, so uh, it will break into x1 and x2. So x1 here it is a triangle and x2 is a rectangle, a gate pulse. So but their time period is same. So if you multiply both of them, it will give us the upward. It is not orthogonal because inner product is not zero. Delta which shifted upward. So the conclusion is x1 is equal to a cos omega t plus phi. Okay, and h2 is a cos omega t plus phi 2. So here we can see that omega 1 is not equal to omega 2. Okay, and phi 1 and phi 2 are true. So and this is the basic formula integration 0 to 2 pi omega 2 pi omega with both the time period of both x1 and x2. So it is 0, so x1 and x2 are orthogonal in the main fact is that they are orthogonal in their time period. Okay, so they are orthogonal in 2 pi omega. Okay, and if you want to find the omega naught of the resultant, so we can find it by the taking the high common factor of omega 1 and omega 1. Okay, so relate. Okay, okay. So this is second case. X1 is a cos omega 1 plus omega t plus y, and this is a cos omega 2 t plus y. So here is omega 1 and omega 2 are same. So when omega 1 and omega 2 are same, so how can we say that they both are orthogonal? So we have to check another condition, that is that this delta phi is equal to 2n plus 1 phi over, which means there should be a 90-degree difference between the phi 1 and phi 2. Then we can say that the x1 and x2 are orthogonal in 2 pi omega. If their omega 1 and omega 2 are same, then we cannot directly say that they are not orthogonal. We have to check the difference between the phases phi. If the phi is the multiple of 90 degree, so we can say that this signal is orthogonal signal. So when DC signal and sinusoidal are always orthogonal. Whenever you see a DC and sinusoidal signal, they are always orthogonal. You don't have to check it. When you be given an x1 A and an x2 is b cos omega naught t plus b, so they are automatically orthogonal. Okay? Here is for example of it. X1 is sine and x2 is positive. So if we want to compare them, we want them to be in the same. Uh, we want both of them to be cos or sine. So we convert the first one as cos. So it will converted in cos t minus pi by 2. Okay. So now here we can see that t coefficient is 1, cos, and the cos t coefficient is 1. So both omega and omega 2 are same. Okay. So now we have to check that this condition delta phi is 2n plus 1 pi by 2. So we can check by integration 0 to 2 pi. We have this sin t and cos t. Here cos conjugate is cos t, so we directly write cos t. Okay, so it will just using sin 2 cos t sin t. Sin 2 is equal to 2 cos t sin t from, so 1 by 2 integration 0 to 2 pi sin 2 is equal to 0. So it gives us the integration 0. So x1 and x2 are possible. So here is another example. So here it is given x1 is equal to 2 cos 2t plus 5 and x2 is 3 sin 3t minus 15. So here omega 1 is 2 and omega 2 is 3, as you can see. So now we found that the method 1 omega 1 is not equal to omega 2. So x1 and x2 are also in this is important. Okay? They are not orthogonal as it is. You can consider they are orthogonal. We have to define that they are orthogonal in their time if they are periodic. So they are periodic in 0 to 2 pi by omega. Okay? If you want to find the resulting omega, you can find it by taking the higher common factor of omega and omega 2. Okay? So let me show. This is the method number 1. Okay. So negative omega naught we will find it by SCF is equal to 3 that gives us 1. Higher common factor between 2 and 3 is 1. So T naught is equal to 2 pi omega. Now using integration, we multiply both of them. So to find 0 to 2 pi sin 5t plus 30 plus 3 0 to